Okay, this is question number 6 from their Unit 5, Lesson 3, Day 2 homework. And so we're going to take a look at describing the domains of these rational functions and explain how you know that your answers are correct. Well, in order for us to determine the domain, what we like to do is to factor the expression, or to look for where the denominator is equal to 0. But the reason I want to factor first is because we might find issues where the denominator and the numerator of the expression are the same. So what we're going to do is we'll simplify the expressions first, then check to see if what goes away and what doesn't, and how that affects the domain, of course. So in number 6, 6a reads that we have f of x equals 4x plus 1 over 3x plus 2. So we'll simplify this if we can, but I'm seeing no way to factor. So what we'll do for the domain is we'll look to where the denominator is equal to 0. We can't divide fractions by 0, so that's what I care about, is where the denominator equals 0. In doing so, this side would subtract 2 to get 3x equals a negative 2. Then I would divide by 3 on both sides of the equal sign there to get x equals a negative 2/3. So the domain of this function would be all real numbers except for this value. So we could write that out, all real numbers except x equals a negative 2/3. I'm going to teach you another way to write this. You can write x is an element of the real numbers. This little e right here means element of. R, this capital R with the second line, is real numbers. And then you put on here x, comma x cannot equal negative 2/3. These are equivalent to each other. So you're welcome to use that trick if you want to. Otherwise, you may write all real numbers except. You could even write out information about the interval notation if you wanted to as well. This would be kind of neat to write. You could write negative infinity, comma, negative 2/3, parenthesis, union with, parenthesis, negative 2/3, comma, positive infinity, parenthesis. And you see that those are the same values, but we're not using those. So it's kind of everything up to this point, everything beyond that point, not including that point. That's kind of a neat way to write it too. So there's the first part. Let's go to part B. Part B reads 5x plus 10 divided by x plus 2. Now I'm tempted to say right away, where's the denominator equals 0? Of course, that's at x equals negative 2. Creates a problem. So this is where the denominator equals 0. But I also noticed that if I were to factor the top, this would turn into 5, pull out the 5 times x plus 2 over x plus 2, and I could see that I would cross off x plus 2. So what we have is this is a hole in the graph at x equals negative 2. However, it still has the same domain. Even if I were to ignore the fact it was a hole, I would say that this would be all real numbers except x cannot equal negative 2. So that would be acceptable. Or you could write it using the shortcuts as well. So part C. Part C reads x plus 1 over x squared. And here right away I'll just set the denominator equal to 0, and that would occur at x equals 0. So what we have all real numbers again, except x cannot equal 0. Okay, and then part D, we have j of x equals x squared plus 3 over x squared minus 9. Again, we just set the denominator equal to 0. Now you might notice that x squared minus 9 could be solved in a couple different ways, or equals 0. We could simplify just using simple algebra here to get x squared equals 9. But then remember when we root this, that x is going to be the plus or minus version of 3. That's where you'll have 0 out. You might have also said, oh, I can factor that in the difference of perfect squares. So we can do that too. So that's the factored version, and we get out the same answer. Either way you want to think about it is fine. You could also use quadratic formula, I suppose, or graph it if you need to see that these are places where the asymptotes would occur. So what I would say now is that all real numbers except x cannot equal plus or minus 3. And that ends question number 6.